Mark, you can get us started.
All right. I'd like to welcome everybody today. We are honored to have Yvon Canay giving a talk. He is one of the most important young econometricians in the field today. He's been with Northwestern's faculty, I think, since 2001, and has rapidly become a full professor. He's currently the HSBC research professor since last year. He has a PhD from the University of Wisconsin and a bachelor's degree from the University of Buenos Aires, from his native land of Argentina. He taught MMSS statistics for many years, starting the econometric sequence, and his paper today is on the use of outcome tests for detecting bias in decision making. And since I can't resist overselling, I have to say that Yvon is just one of the most gifted storytellers I know, whether it's about riding a bus to get to class in college or his efforts to bake a pizza or buy a TV at Best Buy. His stories are always just riveting. And so I can't wait to hear what he thinks about bias and what we can know about that. Anyway, so I hand it over to Yvon.
Well, thank you very much, Mark and Kayla and everybody else who coordinated this. Welcome everybody to the webinar today. I'm pretty excited to be here. And as Mark said, I'm going to be talking about this research that I have going on jointly with Magnus Mogstad and Jack Mountjoy at the University of Chicago, which is titled On the Use of Outcome Tests for Detecting Bias in Decision Making. And broadly is the paper where we're trying to actually learn what can we learn about bias. So two things that I want to say before we get started is like, one, this is still a work in progress. We're actually making changes to the paper as we speak. And, you know, since this is so early in the production of this research, I anticipate that there are going to be big changes that we may be doing soon enough. But broadly, the main message that I'm going to give today is going to stay the same. And second, I wanted to highlight that I try to water down the main conclusions or the way that I'm going to present this today, specifically targeting this webinar. So if you're curious about other details or learning about what we're doing in a greater level of generality, you should feel free to go and look at the paper. Today is just going to be as simple as it gets while retaining the main message that we're trying to give. So let's get started. The motivation for the paper is the one that we wrote in the abstract, which is decisions of judges, lenders, editors, and a variety of decision makers often leads to disparities in outcomes across different groups. And here in this paper, group could mean, race, gender, or any other type of grouping that we care about in the setting of interest. But throughout the talk, I'm going to be just focusing on race specifically for concreteness, okay? And the question is whether and to what extent these group level disparities are driven by relevant differences in the characteristics of these individuals or by biased decision makers, okay? And that is not the question that we are bringing in this paper. This is a question that has been around for a long time. And there's a vast literature that has studied this question. What we're going to do is to come and re-examine this question, taking into account what we learned so far in this literature and what are the things that can still be learned. In particular, if you go back to sort of like the beginnings of how economists jumped into study this question, you have to go back to Becker. And Becker had the idea of how to test for racial bias, really bringing all the tools and way of thinking that economists are known for. And in particular, the way that he wanted to think about bias was in three layers. The first one is that you're going to write down a model. That's what we do as economists. We just model behavior. And Becker said, okay, we're just going to build a model that describes how these decision makers behave. And in particular, in the context of that model, we can define what it means to be unbiased. What does it mean to be non-discriminatory? And we're going to be doing that in math. And then once we have that, we're going to define what this decision maker is trying to accomplish, say maximizing profits, minimizing some costs or something like that. And we're going to derive optimality conditions. And the idea then is that once you have a model where you can define what it means to be unbiased and you can describe how an unbiased agent behaves, that will lead to certain implications that you can then exploit and take to your data so that you can check if the data that you have in hand, okay, is consistent with how agents behave in an unbiased setting. And so, motivated by this idea, there were many studies that analyzed group level disparities in different settings. And something that happened is that some of those did not actually specify the optimization problem faced by the decision maker. It just were more like, you can call it descriptive statistic type of approach. And others that actually did specify the decision problem and were more formal about it, more in line with what Becker originally had in mind, faced challenges when they tried to take these conditions to the data. And in particular, two were very prominent. One called selection bias that I'm going to explain in a minute, and the other one was called inframarginality that I'm also going to explain as I keep going. All right, but in this context, recently there was a paper by Arnold, Dobie, and Yang. I'm going to refer to this paper as ADY. This is a 2018 paper, and apply this idea from Becker to the criminal justice system. And what they did is to use the so-called generalized Roy model to model how judges will behave. And the idea is the judge will decide whether to release a defendant by comparing the cost to the benefit of releasing the defendant. The cost here is going to be given by the probability that this defendant misconducts between the bail and the trial, okay, which is called pretrial misconduct. And the benefits are unobserved to the analyst, the researcher, of the econometrician, but it's something that the judges have to assess whether it is a good idea to release somebody or not. And in a minute, I'm going to put down this in math, and you're going to see what it means in terms of some basic notation. What ADY do is they argue that this leads to a so-called outcome test, where bias can be inferred by comparing outcome probabilities for the marginal Black and marginal white defendants, okay? And something important in this sentence is the word marginal. The idea is that if you think about it, judges are gonna be assessing whether a defendant, should be released or not. And there are gonna be some cases in which it's really clear for the judge that the defendant should be released. There are going to be cases in which it's really clear for the judge that the defendant should not be released. But there are going to be some other cases in which the decision is going to be more borderline, more like it's a lot harder to decide. And that's what we're going to call a marginal defendant. And a lot of the statements and sentences that are behind the outcome test are going to be in particular about this type of defendants that are at the margin. The nice thing about this paper by ADY is that they exploit institutional settings from the bail setting that allows them to overcome two of the common challenges that arise. The first one, remember I said before selection bias, the first one here is that they're going to leverage the random assignment of judges to avoid selection bias. Selection bias refers to a situation in which, imagine you have two judges and one of them specializes in people from a certain group and the other one specializes in defendants of a different group. Okay, in that case, it would be difficult to make comparisons because essentially one judge could have different bar than the other judge, and one specializes in Blacks, the other one specializes in whites, for example. But in the bail setting, that doesn't happen because the minute that a defendant, goes to a bail judge, the bail judge is randomly assigned from a pool of bail judges available. The second thing that they're going to exploit is that they're going to leverage near continuous variation in judges to isolate these marginal defendants. We're going to be using here the fact that there are many, many bail judges available for a given defendant. And this is going to give us enough variation to be able to identify who are these marginal Blacks or marginal white defendants that we're talking about. So that's so far the literature. Sort of like very brief. This is a vast literature. I'm leaving out a lot of things, but we don't have time to talk about all that today. But briefly, you have this idea of Becker coming out with this idea of how to test bias, how empirical papers run into problems, and more recently, this paper came with this particular nice setting where things could be done. And what we're going to do in this paper is go back to this state of the art situation, if you want, and re-examine what can be learned about bias in decision making. And what we're going to show is formal results on when and why we can learn anything about racial bias. And the idea is that this is going to offer a blueprint for researchers who really want to do this, or even those who are just interested in the topic, even if they're not going to apply them in their own research. For concreteness, our analysis is just going to be related to this pre-trial setting that I described before. That is the one from this paper by ADY. But as you're going to see as I move forward, everything that we're going to derive applies to any other setting in which you have a decision maker and you have an I setting where you have random assignments and so on. Okay. If you have other situations in which like these nice features, which are this 1 and 2 that I have over here about random assignments and near continuous variation, are not even present. So, well, some of the consequences or, negative conclusions that we're going to get throughout the middle are just going to be exacerbated in those settings. So the main idea here is that we're going to take the nicest setting available out there. And we're going to, at the end of the day, claim that it is quite difficult to say something about bias. It is possible, but when you do it, as we're going to learn, you have to make restrictions on how the decision makers can behave. And if you're fine with that, then you're going to be able to draw conclusions. And if you're not, it's just going to be very tough to use this so-called outcome test to say anything about bias. So before I move forward, I want you to understand the bias setting, because as I said, we're just going to limit our discussion on this. And I want you to be very clear about how it works. If we understand how it works here, as I said, you're going to be able to extrapolate to other settings easily. So we're going to assume that you have a defendant that becomes a suspect, okay? And this defendant is going to be characterized by 2 dimensions. One is going to be race, here denoted by the letter R, and race could be black or white, here for simplicity again. And then there are going to be other characteristics that are going to be non-race characteristics that we're going to collapse into this random variable B. Okay, so a defendant is just going to be a vector R, B, race, non-race characteristics. This defendant is going to be randomly assigned to a judge, and we're going to denote the judge by the letter Z. Okay, this judge, who is randomly assigned to the defendant, is going to make a decision that we're going to denote by the letter D. And then the D is going to be equal to 1 when this judge decides to release the defendant, and it's going to take the value 0 when the judge decides to detain the defendant. So remember then D1 means release in this context. Now there's going to be a period of time between the bail judge decision and the trial that gets at the end of this process. And this is what we're going to call the pretrial period, the period in between the bail judge and the trial. And this is where the outcome is going to be realized. The outcome here, which is going to be denoted by the letter Y, is the misconduct, okay, of the defendant. It's just going to be 1 if the defendant incurs in pretrial misconduct. It's going to be 0 if the defendant behaves well during this pretrial period. Now, throughout the talk, I'm going to be using the so-called potential outcomes, okay? And if you have never been exposed to potential outcomes, the idea of potential outcomes is just a mathematical notation to describe counterfactual outcomes that could happen to an individual. In this case, it is usually the case, we're going to use the notation Y1 and Y0. And what it means is like, if you take a given defendant, suppose that I am a defendant, then potential outcomes allow me to describe what would happen to me if I were released, and that would be given by Y1, or if I were detained, and that would be given by Y0, okay? And these two could be, counter to fact, meaning like in reality, only one of those things are going to happen to me. I'm either going to be detained or I'm going to be released. But the potential outcomes allow us to compare what could potentially happen if counterfactual to what happened to me, the other event was actually the case. That was confusing. But one thing that it's important to take into account that in this setting, something that really simplifies a lot of the argument is that y0 is identically equal to 0. Why is this? Well, if you're detained, then you cannot commit crime during the pretrial period. So by definition, y is going to be 0 if you're detained. And if you're released, well, y could be 1 or 0. You can misbehave or not. So this is the setting. This is exactly what's going on in terms of a timeline. And I want you to have this in the back of your mind as we move forward. Now, what does the outcome test do in this setting? It essentially concludes that there is racial bias when the probability that the marginal white defendant incurs in misconduct is higher than the probability that the marginal black defendant incurs in misconduct. And so what's the intuition, or like if you just at an intuitive level, you think, why is this the case? Why is this concluding that it is biased? Well, the idea would be that if you have the marginal white defendant being more inclined to commit a crime during the pretrial period than the marginal black defendant, well, that means, okay, that the judges are being stricter with the blacks than they are with whites, okay? And that is the part that is leading you to believe that there is racial bias. As we are going to see throughout the talk, there are settings in which this intuition actually applies and it is correct. And there are other settings in which the intuition runs short. And as intuitive as it is, it's just not going to work. And you're not going to be able to detect bias by comparing these two outcome probabilities. But, if you think about what is it called an outcome test, because at the end of the day, you're looking at outcome, okay, events for marginal whites and marginal blacks and looking at differences in these outcomes to conclude that in the background, there is bias going on. So what are the summary of results? And this is sort of like what I want you to get out of today's talk. We're going to show that this idea of the outcome test is logically invalid in the context of the model used by this paper by ADY, which, by the way, has been used in a variety of other papers. What we're going to show is that such a model does not lead to a valid outcome test in the sense that analysts may find bias when each judge in the model is racially unbiased, and the analyst may conclude no bias when each judge in the model is actually racially biased. And the problem that we're going to describe is that in this model, unbiased judges did not necessarily equalize outcome probabilities for the marginal white and the marginal black defendant. So the model is not set up to do that. Once we learn that, you can just, in principle, you could stop there, but that would just leave you with nothing. Will lead with the situation that you cannot learn about bias. So we're going to study the question, are there restrictions that will restore the validity of this outcome test? And we're going to say yes. For example, with the first restriction, here I'm going to use the letter H because it comes from homogeneity. The homogeneity one is going to exclude race from the cost function. That's one restriction you can add to your model that will restore validity of the outcome test. But more importantly, I'm going to talk about this H2 condition, which is excluding non-race characteristics, this letter B that I defined before, from the benefit function of the judges, okay? And if you believe that's how judges behave, then that is going to restore validity of the outcome test. As I said in the paper, we discuss a variety of restrictions, including these two. For today's talk, I'm just going to talk about this condition A2. And there's a reason for that, which is this condition H2 also gave us something else, which is at some point, we're going to want to take this model to the data and be able to do econometrics, which is not something I'm going to talk about today. But then you can call that the econometric validity of the outcome test. And it turns out that H2, this condition over here, not only renders the outcome test logically valid, but it also allows us to use the so-called marginal treatment effects framework to estimate these probabilities at the margin that we need for the outcome test. And so this restriction H2, which leads to something called the extended Roy model, are going to give us both things. It's going to give us a logically valid outcome test and an econometrically valid outcome test. And that's how we plan to conclude as we move forward. So the outline will be the following. First, I'm going to define the framework model, And once we have the model, we're going to be able to define what it means to be racially biased or unbiased within the context of the model. And also in the context of the model, it will be clear how we can characterize these so-called marginal defendants, the marginal Black and the marginal white defendants. Once we have all that, we understand what the model gives us, then we can move to the second part, which is trying to think about whether this model is giving us what we call a logically valid outcome test. So to do that, we first need to define what a logically valid outcome test is. I'm going to provide that definition. And then I'm going to present to you the main result. And the main result is this result that essentially is going to say this model, as flexible as it is, does not deliver a logically valid test. And instead of providing proofs that are not appropriate for today's talk, I want to give you some graphical illustration. Hopefully, with a couple of curves that I'm going to provide, you're going to get a clear intuition of why this is the case and why the negative result about the outcome test in this setting. Once we are there, I'm going to move to the last part of the talk, which is talk about these restrictions, okay, that restore logical and econometric validity of the test. And in particular, we know that they're going to lead to this so-called extended ROI model. And once we have that and understand that we are getting something now that works, I want to spend some time describing what are the restrictions on behavior that this extended ROI model is going to impose. Because it turns out that the restrictions are non-trivial. And so, whereas in some settings, you may be fine assuming these conditions that I want to describe, in some other settings, the conditions may be too strong for the researcher to credibly say that there's bias in that particular context, even if the model is internally coherent. All right, let's move to the framework. Let me go back to the notation that I defined before. We're going to have random variables that are judges denoted by the letter Z, okay? Defendants that are going to be characterized by race R and non-race characteristics B. There's going to be a decision being made by the judges that we denote by D. And there's going to be an outcome by the defendants that is going to be Y, whether they incur misconduct or not. Remember before that I said a particular nice feature of this setting is that defendants get randomly assigned to judges. So mathematically, that means that judges, which is this letter Z, are independent of the potential outcomes, race, and non-race characteristics. And this is going to be very useful when we try to take this to the data, because in the language of a usual intro-econometric analysis, this means that Z would be a valid instrument for this problem that we have over here. The decision model in the proposed by ADY is one where Judge C incurs in a cost-benefit comparison. So the decision is going to be to release the defendant whenever the cost does not exceed the benefit. Okay, so here lambda RB is just going to be the expected cost of releasing a defendant of race R and non-race characteristics B. And tau ZRB is just going to be the expected benefit of Judge Z of releasing a defendant of race R and non-race characteristics B. Now, there are 5 features of these models that are worth highlighting because, I want you to have it in mind as we move forward. The first one is that the cost of release, this lambda over here, is tied to an observed outcome and does not vary across judges. As you can see here, I didn't index this by Z. And that is because we're going to be assuming that this cost here is just the probability that the defendant incurs in pretrial misconduct, conditional on the defendant being of race R and non-race characteristic equal little b. And so this, of course, is an ideal situation in which you can imagine that judges actually do know the actual probability that a given person incurs in misconduct, okay? As you can imagine, there are going to be settings, or if you want a more realistic situation, in which the judges don't even know this probability and they have to estimate it somehow or approximate it or some other type of manipulation that they will give some information about this probability. But we're going to start with this like simplest case in which the judge actually knows the actual probability. And if we find difficulties with this simplest case, as we're going to describe later, in more sophisticated cases, the problems, again, are just going to be exacerbated. The second thing is that the benefit of release, this function tau over here, is just going to be unobserved by the analyst. So in this part, we need to start dividing things in two. What agents do in the model, in this case, our judges, okay, and what do they observe? And us as researchers or analysts or econometricians observe for concluding that there is bias in a decision setting. We're going to assume that, the actual subjective, if you want, expected benefits that judges may have about whether they want to release somebody or not is not something that we observe. We're not going to see that. So in this decision over here, we're just going to be able to say something about this end, but we don't observe the function on the right. And the question will be, how do we deal with that? Well, we'll talk about it. The third point is that the decision maker, or the judge in this case, that was the fourth one. The third one is that both R and B enter both the cost function and the benefit function. As you can see, even though judges only affect the expected benefits, R and B appears on both sides of this equation, which is important. And the fourth one, which is what I was mentioning before, is that the judges are going to observe both the race and the non-race characteristics of the defendants, but the econometricians or the analysts are only going to observe race and not B, okay? And again, I want you to think this as a simplification for the exposition, because in principle, you can do the analysis divided in like three, right? So you have race, you have characteristics that are observed by both the analyst and the judge and the analyst, and then you have characteristics that are only observed by the judge but not observed by the analyst. I'm going to exclude the middle case in which both the analyst and the judge observe characteristics, because those are not going to create any type of complexity in the analysis, and they're just going to clutter notation, okay? So for simplicity, the dimension that the judge and the analyst observe is just race, and the rest of the characteristics are observed by the judge and not observed by the econometrician. And the final point is that this model doesn't say anything about how two different judges behave relative to each other. It's just a model that says how a given judge Z behaves, okay? And this is going to be important later on as we move on. All right, so now we have a model. This is the decision model. The question is, okay, how do we define bias or unbiasedness in this particular model? Well, the definition is going to say the following. We say that judge Z is racially unbiased if the expected benefit of releasing a defendant does not depend on race. Okay, so you see here tau ZRB is equal to tau ZB. R drops out. And so this is saying like the expected benefit that the judge expects to get from releasing a defendant does not depend on whether that defendant happens to be Black or white. Now we're going to say the judge is racially biased against a Black defendant if the expected benefit that this judge gets from white defendants is higher than the expected benefit the judge gets from releasing Black defendants, okay? And as you can see here, this is an inequality that we write for all values of the non-race characteristics. Again, I'm going to do this here for simplification to make the argument simple, but in the paper, we just consider cases in which this strict inequality happens for some values of this non-race characteristics P, and it could be equality for some other value, so we can accommodate all that. Just for simplicity, let's stick to this case in which bias is, of course, equality, doesn't depend on race, and then a bias behavior is strict inequality for all values of B. And one thing that is important is that in this definition applies to defendants with the same value of the non-race characteristics B. So later, if we think about B as being some skin tone, if you want, the number of tattoos, if you want, or how the speech pattern that a defendant may have, those things are kept constant when you're doing this comparison. So you're comparing people with, say, the same number of tattoos on one side and the other one. All right. We're going to make 3 assumptions throughout the paper. This is the first one. The other 2 come later. And this is the so-called single crossing condition, SC over here. And it says the following. For all judges and races, there exists a marginal defendant that we're going to define as B star ZR. That is going to be the value of V such that the expected cost is equal to the expected benefit. It sets these two functions the same. And there's a single crossings because to the left of this marginal defendant, the cost is going to be strictly less than the benefit. And to the right of this marginal defendant, the cost is going to be strictly higher than the benefit. And so, as you can imagine, and the pictures that I'm going to show you later, think about sort of like two curves that are sort of like supply demand. At some point, they cross. At the crossing is where we identify these persons that are at the margin in terms of this non-race characteristics B. And so moving forward, when I say like, when I talk about the marginal white defendant for judge C, we're going to be using this notation B star ZR, okay, which determines who is the marginal defendant of that given race for that particular judge. With this notation, then we can go back to say, I said earlier, sort of like intuitively, this is what the outcome test does. Well, now you can write it more formally. And you can say the outcome test compares the pretrial misconduct probabilities at the margin, okay? And it concludes that there is racial bias whenever the probability of misconduct for the marginal white defendant is greater than the probability of misconduct for the marginal black defendant. And now we know how to characterize the marginal black and the marginal white defendant. And there is no evidence of bias when the probabilities associated with these two marginal defendants are the same. All right. So we have a model. We know what it means to be unbiased in the model, and we know how to characterize a marginal defendant. Now let's talk about validity of the outcome test. We're going to say that the outcome test is logically valid if and only if the sign of the difference of these probabilities of misconduct for the marginal black and marginal white defendant is the same as the sign of the differences between this expected benefit function. Okay, and this is a minimal requirement because it's essentially saying that differences in outcome probabilities at the margin identify differences in the expected benefits, which is what enters the definition of bias. Okay, and if you just intuitively tell me what is this coming from, well, it comes from saying bias is defined in terms of difference of this expected function, these tau functions, and the outcome test is using these objects to conclude that there is bias. So an outcome test is going to be logically valid whenever these differences are telling you anything about these differences on the right-hand side. And the implication here is that the marginal black and marginal defendant should have the same probability of pretrial misconduct if and only if their common judge is racially unbiased. Okay, so that's going to be an implication of this definition holding for the particular model. So now, before I present to you the main result that I described informally before, let me just list the two remaining assumptions that we need. These assumptions, just to be clear, are going to be sort of like stronger than needed, but it's just they're simple to explain here in the slides. In the paper, we just show that everything carries on if you only assume very local versions of these smoothness conditions. The first assumption that is about the cost function, that is assumption C, says that the expected cost function, remember lambda, is continuous and non-decreasing in B. And assumption B, which is about the benefit function, says the expected benefit function, tau, is continuous and strictly increasing in B. Okay, and then the note here, just to repeat and be clear, neither monotonicity nor continuity are required to prove the result that I want to show in the next slide, but it makes the exposition simple. And in particular, in the paper, we show that as long as there are some areas in the support of B where you have some continuity and monotonicity, then the proof goes on, okay? But in principle, these functions could be allowed to be discontinuous and, oscillating up and down and so on. It's just that it makes the argument and the presentation more complicated to go through those more general cases than it does if we just stick attention to this particular simplified set. All right. That's where we are. Now we can present the main result. Let assumptions single crossing about the cost function and the benefit function whole. Those are the only three assumptions in the paper. Suppose that judge Z is racially unbiased. That is, expected benefit function does not depend on race, according to the definition that we provided before. Then there are DGPs, where the marginal white defendant exhibits a higher misconduct probability than the marginal black defendant. This happens, okay? So what this is saying is like, look, here you can have a model in which judges are perfectly unbiased, not even taking into account race into their expected benefit function. Yet, when you just go and look at the probability of misconduct of the marginal white and the marginal black defendant, you can find that the probability of misconduct of the marginal white defendant is strictly higher than the probability of misconduct of the marginal black defendant. And this is what the outcome test will use to conclude that there's bias. And then 2 says, suppose the judge actually discriminates against black. So here we have a judge that's a benefit for whites strictly above the benefit for blacks all the time. Well, our result says that, well, there are DGPs where you're going to find that the marginal white and the marginal black defendant have exactly the same probability of misconduct, meaning the test concludes there's no bias, or even worse, you can find a situation in which the inequality goes in the other direction, and you're going to conclude that there's discrimination against whites in a model in which judges consistently discriminate against blacks. So as I said, I'm not going to provide a proof, but let me show you some simple pictures that hopefully will give you an idea. On the horizontal axis, I'm going to just plot here B, the value of the non-race characteristics. And on the vertical axis, I'm going to just define the, I'm going to plot the probability of brutal misconduct, or if you want, cost and benefit functions. Here, the benefit function, tau, is just, doesn't depend on race. So it's just one line. And the expected cost here is just the probability of misconduct for white defendants. So see, red is just for whites, and it's of course a function of B. At the intersection of these two is where we find the marginal white defendant, is the individual that sets these two curves the same. And that gives us the probability of brutal misconduct for this marginal person. Well, now hard to see that now if you look at the probability of misconduct for black defendants, and if this line now fits, to the right of the red one, then you're going to find that the intersection is going to happen at a lower point, and we're going to find that the probability of brutal misconduct for the white is strictly higher than the probability of brutal misconduct for the black. So even in this model, where you can see the judge do not take into account race when they consider their expected benefit, you can still find differences in the brutal misconduct probability for marginal defendants. And the test will conclude that there is bias. This is the first part of the theorem. In the right panel now, we can think about the second part, where we have a judge that consistently discriminates against blacks. That means that the benefit function is always above the, for the whites, is always above the ones for the blacks. And then again, you can plot the cost for the whites. At the intersection, you get the marginal white defendant. And now you can imagine having an expected cost function for the blacks line to the left, this dotted blue. And then at the intersection with the dotted blue line, you can have a marginal black defendant with the probability of misconduct strictly higher than that of the white defendant. And then, of course, you can manipulate this picture, and make them the two being exactly the same. And this gives the situation where you have a judge where is strictly biased against black defendants, yet the marginal individuals have exactly the same probability of misconduct. Okay. So as I said, this is not a proof. There's just some heuristical graphical illustrations, but hopefully give you an idea of what's going on. The problem is that in this model, judges equalize outcome probabilities for the same value of B. This is something that I stressed before. Yet most often the marginal white and the marginal black defendants have different values of B. They don't necessarily have the same value of B. And so that's why the model has such much difficulties into going from outcomes to the description of bias. The implications, if you just go and think about an applied paper using this, and if you think about testing in particular, if you want to test for bias in the statistical definition of a test, well, you're going to have a test that will have no size control, okay, under the null hypothesis. It will over reject. And then it will have no power because, you can have situations in which there's bias and the test tells you that there is no bias. You think about confidence intervals that you could do by using marginal treatment effects, they're just going to be invalid. So, of course, if the test is logically invalid, it will not lead to anything data dependent that is going to work out. Just not going to work. And the summary is that differences in these outcome probabilities are uninformative about differences in expected benefits, which is what determines whether the judge is biased or not in the model. So the natural question is, okay, this is fine. This looks hopeless in a way. Are there additional restrictions that will give us validity? And the answer is yes. And as I said, there are different types of restrictions, but today, due to time and the purpose of this talk, I'm just going to focus on the situation in which you restrict this tau function, which is expected benefit, to not depend on the non-race characteristics B. And that will be the last part of today's talk. So we already talked about the framework. We talked about the main result and how the test is logically invalid. Now I want to talk about restrictions that restore logical and econometric validity of the test. And so in this case, the question is, can we get a logically valid test that we can take to the data and identify the probabilities of interest via the so-called marginal treatment effects? Okay. And as I said, either you are familiar with the marginal treatment effects or not. I won't have time here to review this, but I want to just explain briefly in one slide how this works. But conceptually, what you want to have in mind for this part is like we had this general model, which was called the generalized Roy model. That model is logically invalid. Now we want to fix it. But there are two things that we need to take into account while fixing it. One, we want the model to lead to so-called logically valid outcome tests. But two, we want the model to be such that when we get data and we estimate these quantities from data, that the approach is identifying what we want it to identify. And so let's talk briefly about what are the econometrics behind the outcome test. The outcome test requires to identify the misconduct probability of marginal whites and marginal black defendants, this lambda at B star that I explained before. Well, that is not a trivial task because we need the data to identify who are these marginal defendants. And it turns out that without restrictions, the model does not recover misconduct probabilities for marginal defendants. Okay. And the reason is that the model that I presented tells a story about how a given judge behaves, but it doesn't say anything about the relative behavior of two different judges. And so in order to be able to take this to the data, if you start working on the math and the arguments behind, you very quickly realize that what you need is restrictions that go across judges. That is, in the simplest case where we have two judges that tell us something about what's the relative behavior of these two judges. And that condition is called monotonicity. Monotonicity says that exogenous reassignment from one judge to another weakly increases the benefit function and thus the likelihood of release for every defendant of a given race, okay? And so it gives us this inequality over here for two judges. We know here R and B are constant. The only difference is judge Z and Z prime, okay? And what this means is, again, go back to the two judges case. Suppose that you have two judges. One is a tough judge and the other one is a more lenient judge. And what this is saying is that if you have a defendant that is released by the tough judge, well, that same defendant would have been released also by the more lenient judge. And in the other way, if you have a defendant that was detained by the more lenient judge, that same defendant would have been detained also by the tougher judge. And it gives us a ranking. It gives us a ranking in terms of leniency of the judges, okay? And this assumption is called monotonicity. And if you assume this, then we can now use this machinery of the so-called marginal treatment effects, which I said I'm not going to review, but the marginal treatment effect identifies this treatment effect, the difference between Y1 and Y0 for a marginal person of race R. And in the end, this is just the probability of pretrial misconduct for a marginal person of race R. So here you see that I'm using the so-called propensity scores instead of the B that I had before. There are some manipulations that go from one to the other one that I'm not going to discuss. But the main important lesson here is that there's this econometric machinery that allows you to estimate all these quantities. And in order to use that machinery, we need to impose this monotonicity assumption. Then you say, great, so we have this monotonicity assumption. Is that something that restores the logical validity of the outcome test that we described before? The answer is no. This fixes the econometrics, but doesn't fix the logical validity of the test. So then, can we get both? Can I get a logically valid and econometrically valid test? And the answer is yes. You can do so if you use what is so-called an extended Roy model. And the extended Roy model is the same decision model that I wrote before, except where you impose a restriction that I mentioned before, where the expected benefit function does not depend on the non-race characteristics B. Tau ZRB is just tau ZR. Okay. And then if you just consider this decision model, which says that benefits may vary across judges, but for given judge, benefits might be identical for all defendants of the same race, no matter their non-race characteristics, this delivers a logically valid test. I'm not going to prove it here, but in the paper, we show that this simplified model gives you a logically valid outcome test, a model in which differences in outcomes lead straight to differences in behavior and biased behavior. And not only that, this model also satisfies the monotonicity assumption that I explained before. So it allows you to take the model to the data and use data to say something about bias. It gives you both. Now, this is great. And then you can say like, okay, we're done then. We have a model that, we can say something about bias and we can take the data, and that's true. The one thing that it is important in this, adding restrictions to models are not innocuous. Typically, they lead to restrictions on behavior. And here, there are two that I want to highlight. The first one is that this model says that there are no forms of bias other than racial. Or in other words, a biased judge must be equally biased against all defendants of the same race, okay? Because there's nothing else going on. B doesn't enter. And this is at odds with the body of empirical evidence, suggesting that prejudice can vary in magnitude with a wide range of characteristics, including skin tone, facial gestures, speech patterns, height, and so on. So other things that typically affect the decision makers that are deciding whether, say, in this case, to release a defendant or not, that go beyond race. Whereas this model tells you those should not play any role, okay? This model tells you that the only dimension in which you can have bias is in race. The other thing, I go back very early in the talk when I said we're going to assume that these judges actually know the probability of paternal misconduct. Well, in reality, they don't. And judges, typically try to predict this probability, okay? And if they fail, it has to be that this is called measurement error, that the failure at getting the actual true probability cannot vary systematically with B, cannot depend on these other characteristics. It has to be the same regardless of B. And this is at odds with some work that is out there that compares the decision of judges with, say, machine learning algorithms. And then that shows that judges tend to underestimate defendants with minor current charges, but strong prior convictions, and judges overestimate low-risk defendants that face a more serious current charge, okay? So the lesson, you can stare at this, you can think about it, and of course, you can look at the paper, but is that you have a model that gives you a valid outcome test and a valid econometrics, but that it imposes serious or non-trivial restrictions on the behavior of the judges. So we have 2 slides to go. We're about to finish. Let me conclude or touch on broader lessons before we move to the concluding slides. First is that the results apply to other environments that are shared institutional features, okay, with pretrial release. In particular, any nice setting where you have random assignments of decision makers and you have many decision makers that are used for the comparisons, okay, this includes criminal sentencing, welfare eligibility, as I said, lending credit process before. These are cases in which exactly the same results that we describe here would apply to those, okay? And these are what we call nice settings. However, more broadly, the challenges that we describe in this paper also are present in cases that are less nice. For example, in cases when you don't have random assignment of judges, you don't have a lot of judges, but you have just a small number of decision makers. Well, that only is gonna make the discussion about going from outcomes to bias more difficult, okay? So we don't concretely analyze it here, but it's just a consequence of the analysis that we have done. And the lesson is this, if you want to put it in words. A valid outcome test requires a model that is restricted enough to deliver empirically distinguishable characterizations of bias versus unbiased behavior, but rich enough to incorporate the essential elements of the optimization problem faced by the decision makers. And this is the trade-off. You want to have a model that is really general so that you can say it models behavior quite broadly. But the problem is that if you go to a model that is too general, then you can just no longer link outcomes to discrimination. So you simplify a model, and now you can link outcome to discriminations. But then now you're with a simplified setting, which may put strong restrictions on how you're allowing your agents to behave. And in the context of this paper, this trade-off manifests in the choice between alternative versions of the Roy model. The generalized Roy model, which is the one we started with, more general, B enters in both sides, versus the extended Roy model, which is one where B does not enter the benefit. So let me conclude. This paper hopefully helps researchers understand when and why the outcome test would be expected to work well, and when you would expect the test to work poorly. And the main highlights are the following. First one is the difference in outcome probabilities are uninformative about differences in benefits, and that is bias in a really general model like a generalized Roy model. And then also that a valid MTA representation requires cross judges restriction. Remember, the model doesn't tell you anything about the behavior of two different judges, but in order to take this to the data, we need to start assuming the so-called monotonicity condition, where we just impose that, there are more lenient judges that are related to stricter judges. Importantly, assumptions that fix one may not fix the other one. For example, you can impose monotonicity from the get-go that will not make the test logically valid, okay? But there are restrictions that give you both. And that was, for example, the extended Roy model that gives us both monotonicity and a logically valid outcome test. But, the caveat is that it imposes non-trivial restrictions on judges' behavior. And as I said, in some settings, these restrictions that we impose are things that you can believe that they hold, and you can be fine just using this. And in some other settings, the restrictions may be too strong to make this model actually functional for the setting. And that's about it. That's essentially the main thing that I wanted to cover. And I hope that you guys got at least the basics of it. Oh, hold on a second. I can't hear you well.
Is that okay? Can you all hear me?
Yeah, now I can hear you.
Sounds good. Thank you again so much for joining us for this chat. We have a couple of questions. We only have a few more minutes left of our chat. So the one question I wanted to make sure we covered is, can the outcome test be applied in other areas? For example, medical decision-making or anything like that?
Yes. So as I said, the outcome test has actually been applied to a variety of different areas. And the most important thing is that if the data that you have for the analysis is nice, okay, as the one that we have in the trial setting where judges are randomly assigned, in medical decisions, for example, is not typically the case that you get randomly assigned to a doctor, right? So you have a problem, you just go to a doctor, and then these problems that I called before selection bias may arise because, it happens to be that the doctor that is a specialist on this particular disease also happens to, favor a particular group, okay? But in any setting in which you have a situation in which you have random assignment to the decision makers, the outcome test, as described here, is going to arise. Is going to work. And the conclusions that we're going to describe and are going to apply. That's what I mean. But the important thing is that even in other settings that are more complicated, in particular, say in a medical setting, which the doctors are not randomly assigned, well, the difficulties that we highlight here would also apply there, plus the additional complexity that you don't have decision makers randomly assigned to patients.
Awesome. Mary is wondering in the Q&A chat feature, is about gender. So is gender something that was considered in this aspect, or something? So if you could talk about maybe how dependent text or gender was
in some applications, the focus could be on race. In other applications, the focus could be on gender. It doesn't matter, just notation here. What matters is groupings, okay? You have groups that are treated differently. And, in other countries could be castes, okay? It doesn't matter what these things are. You just relabel things, and the same intuition apply. Outcome tests have actually been used in cases of gender. Could be also discrimination in age for certain, say, work positions and so on. So in the setting, you need to define what are the groupings that are relevant for the discrimination question. And then once you define these groupings, and they're not, not necessarily they have to be two, like black and white and men, women. There could be multiple groups, but typically, at least for the discussion that we do in the paper, they have to be discrete.
Sounds good. And the last question I'm going to ask is if folks are interested in this topic, do you have any books or articles or any further things that people could check out if they're interested in this topic?
Sure. Well, I started talking about Gary Becker. Becker wrote a book. It's an old book from the 70s. Okay. So even though there's a book, I would probably not recommend people to go there because it's just in a way outdated. But there's a nice review paper by Nicola Persico, which happens to be one of our colleagues at Kellogg. It's a 2009 paper in the Annual Review of Economics. And it's a really nice paper that surveys the literature and discusses issues. It has examples. So I think that it represents a good starting point to get sort of like a sense of what this literature is about without having to read 200 pages.
Sounds good. I hope you all join me in thanking Yvonne with a virtual applause or wherever you are joining us from, an applause at home. Thank you so much, Yvonne, for joining us. I'll introduce myself really quick before we sign off. My name is Kayla. I'm a program assistant here in Econ. Thank you all for joining us. We'll be doing another alumni talk in the spring with Professor Seema and Mar. So that'll be on environmental conservatism. So that should be really exciting. So I hope you all join us for that as well. And thank you all for joining us. I'm going to sign us off now, but thanks again, Yvonne. And
Thank
hope
you.
to see you all again in the spring virtually.
All right. Well, thank you very much.
Thank you. Have a good day, everyone.
Bye.